Okay, now let's proceed with the next example. Right. So now your problem is heating and humidification. Okay. So you have state number 1, state number 2, and state number 3. So what happened here? Let's say your problem is 1 atm. Okay, 1 atm pressure. So if it is 1 atm pressure, you can use psychometric chart, right? So let's assume this is your psychometric chart. So what happened in your process is this is state number 1 and this one is state number 2. Alright. So first there is a heating coil between state 1 and state number 2. Okay, as you can see, omega 2 also equals to omega 1. So basically the process is just a straight line. It's a simple heating. Now next, there is an increase of a humidifier. There's a humidifying section. We add water content into the test section. Okay, so this is state 1. This one is state number 2. So if you add up humidifier, we add the water content, what happens is your process is gonna look like this. So this is state number 3. Alright, so this is what happened. In order for you to calculate let's say Q dot and all, the humidity ratio, the m dot water. Okay, so you're going to use all the information at state number 1, at state number 2, and state number 3. Right, similar like my previous example before. Okay, for 1 atm pressure. Okay, let's take a look at example. Okay, so instead of 1 atm, let's change this one into 100 kPa, right? 100 kilopascal. Okay, since this one is 100 kilopascal, okay, in the case of psychometric chart and calculation, alright, for air conditioning, 100 kPa is not similar to 1 atm. Okay, like perhaps you deal with a previous subchapter, chapter, which is you assume 100 kPa equals to 1 atm. For this case, it's no. Alright, the value is going to be different. Later I will explain to you. Prove to you the value is going to be different. Right, for 100 kPa now, you cannot use psychometric. We need to use calculation. Right, we need to use calculation. So other than 1 atm, 100, 90 kPa, 70 kPa, the process occurs at different pressure other than 1 atm. You need to use calculation. You cannot use psychometric chart. So let's proceed. We assume 100 kPa, not 1 atm. Okay, let's read the equation. Air at 100 kPa, 10 degrees C and 30% relative humidity at 45 meter cube per minute is first heated to 22 degrees C in a heating section and then humidified by introducing water vapor. Okay, the air leaves the humidifying section at 25 degrees C and 60% relative humidity. Okay, so how about if I'm just using this figure for this case. Alright, so you have T1 equals to 10 degrees C, relative humidity 30%, and then V dot 1 equals to 45 meter cube per minute. Right, next is temperature 2, 22 degrees C, and we have temperature 3 equals to 25 degrees C, and then relative humidity at state number 3 is 60%. Okay, so they ask you to calculate the rate of heat supply in the heating section. So meaning this one is Q dot in, and the next is the mass flow rate of the steam required in the humidifying section. So this one is M dot W. Okay, not M dot A. This is actually M dot W. Okay, so we're going to start with problem A. We need to calculate Q dot in, which is equals to M dot A H2 minus H1. So first, we need to determine partial pressure of water vapor, PV1, which is based on relative humidity multiplied by the pressure of saturation, okay, which is equals to P saturation. So for our case, it's actually at 10 degrees C. So this one is going to equals to 0.3 multiplied with, so now we need to take a look at the property table at 10 degrees C. Okay, so at 10 degrees C, the saturation pressure is 1.2281. So this one is 1.2281 kPa. So equals to 0.368 Pascal. Okay, so this is the partial pressure of water vapor. So next we need to determine the partial pressure of dry air, which is equals to the operating pressure multiplied with divide with PV1. So this one equals to 100 minus 0.368. So become 99.632 kilo Pascal. Right. So next we need to determine the specific volume. Okay. This one is, remember the equation of PV equals to MRT, so it's the same. So the RA T1 divided by partial pressure at state number 1. So basically we determine the specific volume at state number 1. So So this one equals to temperature 273 plus 10 degrees C, 283 Kelvin. This is gas constant, so 0.287 divided by 99.632 kilopascal. So this one will be equals to 0.815 meter cube per kilogram dry air. So this is the specific volume. Okay, remember just now I told you that 100 kPa value is going to equals to, it's not going to equals to 180 M. Okay, for air conditioning system it's quite sensitive. Alright, so remember just now here, so we got the specific volume is 0.805. So this is for 180 M. But for this case, since 100 kPa, specific volume is a little bit different, but it produces a quite different value, 0.815 meter cube per kilogram dry air. Alright, so that's why it's not the same. 100 kPa and 180 M for air conditioning. You need to use calculation if your problem occurs at 100 kilopascal. Okay, next we determine the omega 1. So omega 1 equation equals to 0.622 partial pressure of water vapor at that state. Okay, so you put the value, so you're gonna get 0.0023 kg H2O divided by kg of dry. So this is omega. Okay, next is H. Equals to CPT1 plus omega Hg1. So 1.005. So this is specific heat. Okay, multiply with 22 plus the omega 0.0023 multiply with 2519.2. So this value you need to determine from the property table. The enthalpy at saturation position, at saturation value. So we go to the property table. So 10 degrees C. So this one is saturation Hg 2519.2. So this one equals to 15.8 kilojoule per kilogram dry. So next we determine H2 CPT2 plus omega 2 Hg2. Okay, so from here Cp is 1.005 multiplied with temperature number 2 is 22. Sorry, this one is 10 degree, not 20. Step number 1, right? So plus omega 2 is omega 1, omega 2, since omega 1 is equals to omega 2, right? Okay, omega 1 equals to omega 2 because at this moment we state 1 to state 2 just a simple heating, so omega is going to be the same, so 0.0023. Okay, omega 1 equals to omega 2, just a heating process. So take a look at property table. Okay, 22 degrees C, right? So you need to find this X value here. You need to interpolate. So the value is actually 2541. So H2 is 28.0 kilojoule per kilogram dry air. Okay, I'll take this opportunity to move back to the previous example here. Okay, I put the value is the same because I just assume it's the same, but the thing is if you plot it clearly, the value is not going to be this value, right? So I mentioned before, you need to find the value based on psychometric chart. I mean, you need to draw it clearly and find the value. So suppose it's not going to be the same value. Alright, next is Q dot. So Q dot M dot A, we already found the value of M dot A, and then H2 minus H1. So from there, the value is 673. 673 kilojoule per minute. Okay, so successfully solved for A. We find the rate of heat supply in the heating section. So next is B. Okay, we proceed with B. We need to calculate the mass flow rate of the steam. So M dot W. Okay, dot W. So the mass balance of water in the humidifying section. So for humidifying section, M dot W equals to M dot A omega 3 minus omega 2. So this is our problem, right? So this is omega 2, this one is omega 3. So the mass balance of water is actually equals to M dot A omega 3 minus omega 2. So we already have the value for omega 2, okay, which is equal to omega 1. Okay, this value, right? 0.0023. So we need to find the value of omega 3. So the same equation 0.622 PV3 divided by P3 minus PV3. Okay, so similar approach like before, you need to determine PV3, right, from the relative humidity 3 and saturation pressure at, what is the temperature? 22, right? Sorry, the temperature is 25. Okay, 25 degrees C. 25 degrees C. So you need to determine the saturation pressure at 25, which is 3.1698, and the relative humidity is 60%. So 0.6 multiplied with 3.1698. Okay, so you need to determine this value. So next you calculate the omega 3. Okay, you just replace, substitute this value into this equation. Right. So the value of omega 3 0.01206 kilogram per kilogram dry. Okay. So from there you determine the m dot w. So m dot w equals to 0.539 kilogram per minute. Right. So that is the rate of water added into the system in the humidifying section here. Okay, so I think that's all. Next we continue with cooling and dehumidification. Right.